Hello, welcome back. What's up? Welcome back to another video. I don't know why this is showing. This is there. I hope it's just an issue. Let me just check. Yeah, we have power going on. And today I will be solving another lead code question, lead code 69, which indicates square root of x. Given a non-integer, x returns the square root of x rounded down to the nearest integer. The return integer should be non-negative as well. You must not use any built-in exponent function or operator. Okay, we cannot actually in C++ or x to the power 0.5 in Python. Okay, we are in Python. Okay. Ah, Okay, so actually I have done this previously, like when I was doing in college. So I have done it. It's basically uses binary search, and if you don't know any about binary search, let me just quickly uh, look into it. Let me just close the Valorant screen, exit. Yeah, so let me just go and open Paint. Yeah, so we have, let me close the grid lines, the rulers. Yeah, so. Um, So basically, what we have to do is, okay, yeah, this is perfect. So suppose you are, let me represent a number. Wait, control Z. Simply simple. Let's have a number. I'm just showing how binary search works in this. Okay. So once you're sure that this is your given number, this is n. Okay. So the root will be somewhere from 0 to 9 to n, right? So what you basically do is that you first search that whether the mid, which is n divided by 2, okay, which in this case is 2. So here you have found that mid is basically n by 2, and we have found 2. So you just check whether mid square is equal to n or not. Okay, that's the first condition you want to check if mid square is equal to n or not. And if it is equal, I mean, if it's like we do it and after that we can round it up. And if we find that mid square is equal to n, then we just return mid. Okay, now suppose we find that mid square is less than 4. This means that we are okay. Then we have two cases. Okay, just a minute. Okay, so we have another case that is mid greater than n. Let me just erase this as well. It will be n. Okay, in n. Now what happens is that mid is root n, right? Mid is greater than root n. So you basically do so this is mid square. Mid is less than n, so n, and this is mid square n. Okay, now how this happens, that you definitely know that so I'll just I think I need to explain the algorithm in better detail. um okay, let me just explain in this picture as well. Okay, Forget about the numbers. Forget about the numbers. Let's just keep n, and we have mid. Okay, let's give it n. Okay, let me just erase it again. We have black. Yes. Suppose this is n, this is mid. Okay, m. So basically, what you do is that uh, you definitely know that for any given number n, the square root will be somewhere around in the number line from 0 to n. So what you basically do is that you find its half, which is a point of comparison, or you can say a point of reference for that number, for the square root of the number. Okay, so what you do is you find it, that is n, and basically what you do is that you do 0 plus n divided by 2. Okay, and there's also an a formula which actually handles the integer overflow case. So we will do it while I'm writing the code. I will tell you how that is written, but this is how it's done. Like, you basically start n and divided by 2. I will tell you what start and end. In this case, start is 0 and the end is n. So you find m is equal to n divided by 2. Okay. So once that has been done, you have to look out for this, whether mid square, because you want to find the square root. So mid should be equals to square root of n. So you want to find out that whether mid square is equal to n or not. Okay, in some cases, like we have seen here, that n is equal to 4, you directly find the value that mid mid equal to n divided by 2 is actually 2 itself. So that's the square root of 4. So that's a very straightforward square root. However, that won't generally be the case. Most of the time you will be finding these two. Okay, that's mid square is either smaller than the n. Okay, or otherwise this is actually mid square is either greater than n. So in that case, when you finding that mid square is smaller than n, that means the mid or this is actually smaller than n case. Okay, so the n or the square root of n lies somewhere here, this position. Hence, what we will do is that we will change the start position from here to here. Okay, this becomes the start and this becomes the end. Okay, and this becomes the end. Okay, and in the case where suppose we are looking somewhere in mid square is greater than n, which means mid is greater than n, right? Mid is greater than square root of n. This means the square root lies somewhere here. Okay, so yeah, the mid lies somewhere here. The square root of n lies somewhere here, and we have actually moved forward to find it. So in that case, the start remains same, but the mid becomes the ending point, and the algorithm continues again and again till we find mid square is equal to n. Okay, so that's the whole algorithm, and now we're gonna code it and see if I'm correct or not. Okay, yes. So let's begin. Right. So let me just increase the brightness. It's yeah, yeah. Okay, that's good. Hmm. Okay. So x is equal to x and e, which is end. The start and end should be equal to 0 and x. Okay, 0 and end. Now Okay. Mm, So how can I define it? Sorry, I'm just getting a bit distracted. Because it was a long day at office and I'm not feeling that well. So yeah, I don't know how to just okay. Med should be like while true maybe. We'll figure it out how to stop that. While true, let's find mid is 2s. Yeah. So here's the question like e plus 2e and plus e minus e minus s. Okay, I was speaking about a formula which handles the integer overflow. That's like s minus 2 into s plus e, something like that. I don't know. I don't remember actually. 2s should be somewhere around e 2e 2e. Okay, for now let's just go ahead. s s plus s plus e divided by 2 divided by 2. Okay, if mid into mid is equals to x, return mid, and there's something required to like since it is okay. Okay. That's pretty much it. Like, let's just do it for safe cases. And if mid into mid is greater than n or x less than x, and what we have seen is that if it is mid square is less than n, then start we have to shift the start to mid and will remain as it is. Okay, so in that case we will just shift into mid. Okay, and the e remains the same. Okay, and if mid we can just simply go like that, else e becomes, in that case, which is this, e becomes mid, and the continuous. And now about the condition, s should not overlap. Like if this gets reduced, okay, to such point that e becomes lesser than s, in that case we have to actually stop because that will raise error. So for that, I'm sorry, for that we have to be e. Okay, and then maybe cases where just a could be s could be equal to 0, so s could be equal to e, but we don't want that because s plus s, it's in the s, and s square s should will become I don't think so. Yeah, this should be the equation. uh, and if there's like yeah, there's a possibility that this will work, simply will work. Yeah, I suppose that's it. Let's check it out. Mhm. Okay, let's start out. Come on, I just forgot about it. And start and start becomes mid, or else the end becomes mid. Okay. Okay, I think there's time limit exceeded. Yes. Okay. Yes. What could be the error? I suppose. Okay, med is equals to, like, if I put it here, 8, then 8, 0 plus 8 divided by 2 is 4. 4 is equals to not equals to x. So we skip this. 4 into 4 is greater than x, then equal to x. This means that end becomes mid. Okay, so end becomes 4, and we start from 0 to 4. 0 to 4. Okay, yeah, 4. So 0 to 4 divided by 2 is 2. 2 square is not equal to x, but 2 square is less than x. Okay, let's just run this through a notepad. I suppose that will help us a bit, maybe. Okay, it should do. Am I missing some cases? Turn int mid, and lf mid square is less than x, then start becomes mid. Okay, start becomes mid. Okay. This is how binary algorithm works. Okay, so I don't think. Let me check if there's int meaning all integers. Okay, I'm not sure. This sorted property. Okay, when this sorted property comes in, keep in mind that it trying to refer binary search in most cases. It's not like guaranteed that if there is sorted property, then you have to use it, but it has. It generally points to binary search itself. But my question is, why isn't this working? Mm, Why isn't this working? Mid square should be equals to x, return mid. Else if mid square is less than x, then start uh, becomes to mid, and else otherwise end becomes mid. Okay, yeah, that's pretty much it, I suppose. Okay, okay, wait. I think, yeah, we have to find the difference, right? Like 0 plus 4. Suppose we have 2 and 4, then 3, which is, yeah, that's pretty much the. Uh, I don't see there's any issue. Hmm, And about the n into n, something like this. Okay, leave it for now. I'll look into it. But why isn't this working at all? Hmm? Why isn't this working? Am I missing any while condition? I mean, this should, like, okay, this should somewhere. Should I just convert this into int? Should I? Yeah, should. I mean, I'm not sure. This should actually convert in, no. We are still lagging behind. Should we look into the editorial? Is it? Oh, come on, man. Okay, let's see. It's an editorial. Let's see the solution of Deepak Yadav. Shout out to him. It's binary search. Okay. Okay, this was the formula that I was speaking about. Start plus and minus start. We don't need shuffle. Let's just change that first. Let me just read the approach. First, check if x is 0 or 1. If it is, we know that square root of so we okay. That's a good check. Return x if uh, x is equal to 0 or x is equal to 1. Return x. Doing 1 and x. Why 1? Come on, we should find some. Okay, okay, why 1? I mean, what if, okay, the value will never go to, okay, that's a good point actually. The value will never, like, for any natural number, the square root will be always greater than 1. Okay, square is equal to x. Yeah, we have found the square root. So we, if the square of mid is less than, we know this upper half is, so we right continue. Yeah, that we have done. If becomes greater than s and pointer at this point, we have found the floor value of the square root. Yeah, yeah, yeah. Mm-hmm. Let's see. And mid is equal to minus 1. Okay, so we have to find equals, okay, and we will find dot plus and minus. Okay, and minus dot, sorry. I've been looking into it. I was searching for this formula. I knew this formula would come up somewhere. It is like used predominantly in binary search, so remember. Okay, so x is, yeah, this, x and mid. Okay, this is like, yeah, I mean, we should use this left mid minus 1. Why should be mid minus 1? Like, what if, okay, okay, should this work? Looking for some chow, come on. Yeah, sure, man, like, yeah, I'll just report where it is. Like, how do you do it? We have seen the solution. So, is it like, where is it? Oh man, the interfaces. Okay, I will import. Sure. Stand. Yes. So R mid is equal to L. Yes. If Not sure actually about this. Okay, that work. Hmm. I need to study to ensure victory till the start pointer becomes greater than end. At this point, we found the floor value. Okay, the square root, which is number and help and equals that. Okay, fine. I think this is the solution. This optimized solution. Okay, just submit it. I was pretty much close solving this, but there were some mesh cases. Yeah, shout out to the person who actually wrote the solution. Uh, how can I just upvote it? Is it, yeah, this is how. Okay, come on, man. How do you upvote it? I mean, really. Okay, okay, you upvote it here. Yeah, thanks, man. Thanks. So here we solved another question. Maybe tomorrow I will shift to some like medium type of question. I've been solving easy question for the last 3 days now. 4 days, maybe 4 or 5 days. I need to move a little bit um faster. I mean, there's nothing about faster or slow. I'm not competing with anyone. But yeah, I need to just upgrade myself. So I'll try to solve any medium level question tomorrow. So that's it for today. And it would be great if you subscribe to the channel and press the like and the bell button. Uh, yeah, thank you.